Good afternoon, everybody. I'm pleased to be a part of this webinar on green buildings, essentially, where we are going to talk about optimizing electricity and water use during the summer. Thank you so much for the overwhelming response that we have received. And there are several participants who have already sent in their questions, and therefore the focus is largely going to be on electricity conservation given the time crunch. And we are here, all of us, accepting questions, so please feel free to write it. And I start with the presentation now. Traditionally, as a society, Indians have believed in durability, longevity of materials, recycling products, using local scale and material. Over time, we've preferred that we grow our own vegetables and do not depend on refrigeration of frozen food too much, because that also calls for a pressure on the resource use, and worship nature in terms of praying to trees and also following practices that were inherently protective of the environment. However, over time and with the change in our lifestyle, we have contributed detrimentally to our environmental issues and resources. For example, and I'm sure most of our audience are familiar, greenhouse gas emissions, generation of wastewater, all the waste that gets generated due to our lifestyles and activities that take place in buildings. There are serious health issues and well-being issues that are coming up for dwellers of the city. For example, this is just a picture that shows how there is stagnated water, which would be a potential cause for a disease. Similarly, the buildings are responsible for lots of emissions. And given that a significant part of our society follows these lifestyles that have such an impact, I'd like to identify and look at some of the myths that are associated with lifestyles. One is that spectacles would equate to intellect. However, spectacles and people who wear spectacles only reflect the fact that they are living in places or working in places that do not have enough visual comfort. That is to say, if there's too less light, or there is glare, or there are other issues because of which they're not able to see properly. Similarly, because thermally it's not a comfortable place, either it's too hot or it's too cold, people have got used to using air conditioners and therefore have started dressing in a manner which requires business suits and not conducive to our kind of lifestyle, especially in the summer. And similarly, glass buildings are perceived to be a status symbol, because I believe that's a perceived notion of development that we've come to harness over time. However, glass buildings in many cases, and several very close to us, also require cooling in the winter, unfortunately, because of the large amount of heat that they absorb. And it's very different from what architectural practices are followed traditionally. So therefore, given that from a traditional lifestyle we are moving towards such detrimental impact on the environment, it is important that, and buildings do play a role, it is important that we fine-tune our lifestyles to see how our environment footprint can be minimized or optimized. And buildings in that aspect have a significant role to play. It is our responsibility to provide a healthy and resource-efficient urban environment, and in that light, green buildings have a significant role to play. Just to encapsulate and talk about them briefly, a green building is a building that has minimum impact on site and surroundings. So these could be the trees that are on site, or other water bodies or natural elements on site. And even when construction is happening, one must try and ensure that there are minimum invasions on sites where construction is not happening, and projects that comply with this basic respect to site and surroundings would make a green building. Similarly, green buildings, and this is something I'm going to explain in greater detail, look at energy efficiency and enhance the use of renewable energy so that the pressures on grid and use of fossil fuel is reduced as far as possible. So there are various tools, and like you can see, there are various tools available for analyzing a building design to see that form of the building and shading due to the form can help in cooling or minimizing heat that comes inside the building. Somehow daylighting can be integrated over here to see that once the heat intake is minimized or optimized, it can be provided for by efficient systems and as far as possible offset by renewable energy systems. Similarly, green buildings also endeavor to optimize or minimize the water requirements, not only within the building but also outside that may be required for landscaping, etc. And see that solid waste segregation and other practices, there are provisions and ways to generate energy out of waste that can be included and contribute to resource efficiency further. Similarly, while there is a significant focus on thermal and visual comfort for people who are going to occupy buildings, green buildings must also look at the health, safety and sanitation conditions for people who are associated with the construction. So these are photographs that show how safety gear has been provided, masks have been provided to construction workers, and a project that complies with these requirements would be called a green building. A basic question that I am often asked are that if we incorporate one feature, say like rainwater harvesting or using CSLs, then would my project qualify as a green building? And secondly, what is the difference between making a green building and a rated building? I'm sure a large part of the audience may not be familiar with the rating system, but given the kind of questions I have been asked before this, I think it is apt that I bring it up here. So while a building can be green by incorporating either of the measures that have been mentioned here, a rated building would necessarily have to meet certain parameters. So for example, for electricity consumption, a minimum kilowatt hour per square meter per annum, if that is achieved, then, and there are other aspects considered for resource optimization, then a building is said to be rated. How do these principles work at a building level? Because all this is very well in terms of energy efficiency, water efficiency, but fundamentally the buildings are designed to cater to two requirements. One is to ensure that the people or the occupants inside the buildings are comfortable and they can work and carry on day-to-day activities easily and effortlessly. Why I say this is because one way of looking at a building is that we can switch off all the systems, we can switch off the air conditioning, the fans, save electricity but not be comfortable inside. So with the prime objective of ensuring that the occupants are comfortable as far as their physical surroundings are concerned and as far as visual comfort is concerned, with this major objective is the need for use of electricity in these buildings. So just to give an example, I'm going to just give an example of this. So for example, in our, if we have a building, say typically in a place like Delhi, which in summers needs to be cooled and in winter needs to be warmed, then the typical sources of heat is the sun, because the sun is going to be responsible for a lot of heat that comes in. So there are sun rays that come from here like this and from here, and therefore it is important that in order to maintain thermal comfort inside and be comfortable in terms of temperatures that are maintained, we have to ensure that there is minimum heat gain from the envelope, which is essentially the roof, the wall and the window. After this, once we have optimized the heat that comes inside the building, our next strategy should be, and ideally is for all buildings, is to control or optimize the heat that is generated within the building. So for example, light bulb is a source of electricity generation and heat generation within a room. There are appliances that can be used. There are people who are within the building, and all of these contribute to generating heat. So when there is heat coming from outside and there is heat being generated inside, in order to be comfortable, we need to put ventilation techniques or fans or air conditioners, and which is where we need electricity. Now coming back to the presentation, I'm going to take step by step on how each of these strategies can be addressed and what is it that as consumers and as occupants of these buildings we can do at a day-to-day level. So for example, like I just mentioned, we have to minimize the heat which enters the building. we have to optimize the heat which is generated through bulbs or fans, and you will be surprised to know that if I am using a 100-watt GLF bulb, it requires 100 watts to remove that heat generated. So more than 95% of the power which goes into the bulb is actually generated and released as heat. And the glass, the outer periphery of that glass is actually goes up to a temperature of 130 degrees. So when I have to put a fan or an air conditioner to cool that place, I actually have to ensure that that heat is removed. So I'm first generating heat and then putting an air conditioning system to remove that heat. Furthermore, we have to use efficient appliances, not only because they release less heat, but also because they optimize electricity consumption. And last but not the least, we should avoid using artificial light. Like I mentioned, any appliance or light or gadget that is used would be releasing heat within the space, and we should use daylight as far as possible. Just explaining a little bit more and coming back to the first point on how we can minimize heat penetration, you can see that the sun's rays are coming through the roof. So there are various treatments that can be given to the roof. There are ways in which we can work on the ratio between the wall and the window, because like you may be knowing, more heat can come into a single normal glazed, single window, single glass, and it will take the heat longer to penetrate through a wall. And of course, in order to ensure that the heat does not come in and that light comes in, there are various types of glass that can be used. There are also shading devices that can be used, which ensure that usable daylight comes, because unfortunately what happens several times is that if there is a lot of glare that comes in from the window, we are forced to put curtains or blinds. As a result, switch on lights and bulbs and all of that, which again leads to heat generation and electricity consumption. This is just an image that shows how shading can be used. So for example, west, which in our conditions is the direction from where maximum amount of heat comes, could be shaded with trees, or at a micro level we can look at insulating the roof. In this case, we've used a garden to ensure that the heat does not directly come inside the room, which has to be made comfortable for the user. This is another example where inverted pots or ghadas that we commonly call have been used, but the only drawback being that even though it's a low-cost technology, the terrace is rendered unusable. So people who have a lot of physical space available can use this strategy, and because essentially you are increasing the thickness of the wall, the heat penetration and the rate at which heat transfers from the atmosphere or from the sun to within the building gets delayed significantly. Another example, and this was done a lot traditionally, is the use of coolers, and as you can see over here, they have been used as roof insulation on a terrace over here. And of course, the final coating can be of any material. It could be broken china mosaic or any other suitable thing. But again, this is essentially increasing the thickness, which will delay heat from entering from the roof inside the building. This is another example of a china mosaic finishing, which will reflect, so which will not even allow the heat to come inside the floor. Another useful strategy that may be used and is cost effective is the use of cool paints or high albedo paints, where you can have a temperature 5-degree surface temperature difference can be experienced, and because that is the degree of as in so much the heat generated in the floor just below the roof is less by 5 degrees. Therefore, in air conditioning and other loads, we will save up to 20% power. There are several easily available Indian brands as well, and I've also put a certificate of a Griha identified and Griha certified product, which is a cool roof that can help minimize the heat that enters the project. I do have a video to show how these cool roof paints are applied, but I'm going to take it towards the end of the webinar. Now, having looked at minimizing heat penetration through the roof, I move on to the window and the wall. And like you can see in this image, the wall will allow less heat to come in as opposed to a single clear glass, which will of course allow a lot of heat to come in. As a result, so much heat has to be removed from that space, thereby increasing the demand for cooling or air conditioning or setting the thermal comfort requirements. These are images that show how different levels or percentages of the window wall ratio can be used. So essentially, if the daylight requirements have to be met, it can be designed such that there is a good balance between the window and the wall, and by the policy recommendations that have been identified by the Government of India, ideally the window wall ratio should not be more than 60%. Even though a current trend and what is in fashion is that fully glazed buildings are seen, but even in that scenario there are ways to choose glasses which allow the visible spectrum to penetrate and prevent the heat from coming in. And these type of glasses could be used to ensure that our buildings do not become greenhouses. So this is just an example. This could be anywhere in the country or anywhere in the world. And had these buildings been made of single clear glass, single glazing, which is most commonly seen, these would need extensive cooling in summer and sometimes even cooling in winter, because a lot of heat is caught up and it gets trapped in these buildings. This is an example, and a very old example, of a good building where the window wall ratio has been looked at suitably. So you can see that all the windows are shaded and that there is less than 60% of glass that has been used to ensure that the heat gain is optimized. Another factor that you would have seen in traditional buildings is that the walls used to be very thick. The idea being again to delay the heat penetration into the given space. And while it is not possible, we do not have the luxury of space or the luxury of availability of material or skill, we are unable to construct such thick walls. But of course, this technique has been adapted over time. And you can see here that insulation, in this case, is used as a cavity insulation between two walls, can be used to have the same effect, which again delays the heat that comes inside the building. So these are some generic strategies which could be applied for any upcoming building to ensure that the heat which is coming in from outside to inside, which essentially adds to the discomfort of the occupant, can be controlled. I already mentioned this, that there are several appliances. So after optimizing or minimizing the heat that comes inside the building, there are several activities that take place within a room, including presence of human beings, which generates heat. And I'm sure all of you can read this, that even lights and tube lights, so artificial lighting during the day, would add to the cooling load. And therefore we should avoid using bulbs where, like I mentioned, the outside temperature of a glass bulb would be anything to the range of 130 degrees centigrade, while that of a CFL is significantly lower. So not only are you getting light, but you are also minimizing the heat generated, which will again reduce the load on your air conditioning system. And of course, I'm sure most of us here are familiar that the Bureau of Energy Efficiency has developed the BEE star labeling, which has been mandatory since 2012 for various appliances, including refrigerators, tube lights, air conditioners, and so on. And this is something that should be used and is now mandatory for everybody to use. But the critical question is, how should I choose my air conditioning? Now, a lot of queries have come around air conditioning and use of fans and so on. So I'm going to focus on efficiency of air conditioning systems, because that is something we all take as a given in our current lifestyle. And this is just an example where we can figure out how a sizing of a system is done, because typically a challenge that is faced by people is, how do I find out what is the right size or the right tonnage for my air conditioner? Tonnage basically indicating the amount of heat that has to be removed from that space. So for example, in a place like New Delhi or any place, say Kota, suppose my room dimensions are 15 feet by 20 feet by 10 feet, and my window facing west is 12 square feet, and I live on a first floor. For 2, then it is easy to calculate the tonnage which is required. So it is very important to identify how the size of an air conditioner can be chosen, because sometimes people have this perception that even in a small room, if a bigger air conditioner is used, it will help or enhance cooling. But what happens is, and what plays a critical role, is setting of the set point, the temperature at which the cutoff level is set. And I'm just going to go to that in a minute. Can you see it? Right. So after sizing, it is important to, I hope everybody can see, do let me know if you can't see. So after we have identified the size of the air conditioning system, because what will happen is that if I choose, say, a 2-ton air conditioner for a room that may suffice with 1 or 1.5 tons of refrigeration, then depending on the set point that has been identified, the system will stop working after some time. But it may not be a cost-effective option. Therefore, it is important to choose the right size, because it is going to have a direct impact on the cost. Now, furthermore, the purpose of putting the air conditioner is to remove the heat from the room, and therefore, like we have used architectural features, insulated the roof, the walls, figured out the window-wall ratio, and so on. Still, if we haven't been able to address these issues for some reason, we can put a false ceiling. This is not specifically for residences, but essentially what one is doing is reducing the volume that needs to be cooled. Provide curtains or blinds. So thick curtains help, because even if the heat has come inside the room, it further prevents dissemination to the area which is occupied by the person, and insulate the ceiling which is exposed to the sun, which will have a significant impact on reducing the air conditioning size. Another common question is in choosing whether a person should use a window unit or should use a split unit. I'm not explaining what these are, because I'm sure everybody is familiar with this. The basic difference being, and the thought which can really help make the decision, is that a window unit facilitates induction of fresh air, whereas in case of a split unit, it may be a little bit more costly. It is usually used in places where there are no windows or there is a crunch of space, but there is no direct or immediate fresh air circulation that happens. As a result, it can have an impact. So while using a split AC, one could use it in a room where there are doors which swing open and allow some kind of fresh air to come in, and so on. And then the typical question is that how do you decide the placement of an air conditioner? So the ideal condition is that it should not, the direct draft should not come either on the face or to the occupant, because what will happen is that while your body temperature is 37-38 degrees, the 13 degrees, the air at which the air is released from the air conditioner, it will make you feel, or the person feel, very uncomfortable. So it's best that it is placed behind you at a height of about 5 feet, because so that a full ventilation within the room can happen as well, and that fresh air also gets inculcated in this. I have interestingly received a query from one of my former colleagues to ask if it is more efficient to put to run an AC at 20 degrees centigrade or to run it at 24 degrees and then use a ceiling fan. Now, what happens is that thermal comfort is why we are using a fan or an air conditioner or whatever. And this comfort, as per the National Building Code, has been defined from 23 degrees to 26 degrees. And of course, the humidity has an important role to play over here. So what has been defined in the code is that between 50 to 60 degrees of relative humidity, a percentage of relative humidity of an occupant would be comfortable. Now definitely 20 degrees is not advised by any standards, but suppose I am to use an air conditioner at 24 degrees and I am to increase the velocity of air, say normal, we can say that the velocity of air is 0.5 meters per second. If I am to use a fan and it increases to say about 1 meter per second, then I can easily enhance my set point by 1.5 degrees. Of course, there are several generalizations I have made in this statement, but if I am to use a fan, I can, and I personally feel comfortable at 24 degrees. It could be anything between 23 and 26. I can easily change it to 25.5. Use the set point, that is, and the fan is going to have that kind of an impact. Another aspect that needs and needs to be integrated in every building that comes up is daylight integration. And of course, needless to say, if electricity for lighting is not used during the day, a lot of heat generation is avoided, and a lot of visual comfort is also provided to the occupants. Okay, now moving on to water, which is something I've taken up very briefly. The same strategy can be used to conserve water as a resource as well, and one needs to first optimize the water demand. So try and save water during day-to-day use, say in the kitchen or the bathrooms, or watering the plants, washing the car, and so on. Use efficient systems that may be for irrigation and so on, and then use of recycled water and integrate rainwater harvesting wherever possible. The simple things that can be done are, say, one can use efficient faucets, or this is just an image that shows drip irrigation system in Israel, where the plants are watered near their roots, and this is a simple rainwater harvesting system that has been showcased. This is another example of grey water recycling system that can save a household up to 5,000 gallons of potable water per year. It's a simple equipment that can be put together and can be used. Right. I want to understand how RO systems contribute to water waste and water energy. I think you've already received the answer. There is no win-win situation, but if possible, recover the salt by evaporation or any other technique, as dispose it off to the surface drains. And what are the other questions? Where do we get grey water recyclers in India? I can find that out and get back to you. Does government provide any support to encourage their sale? Actually, it's unlikely. I'm not aware of it, but it's unlikely that the government would give financial support. People do not have much awareness about these things. That's right, I agree. And that is not only for waste-related matters, but several other issues around sustainable habitats that need to be addressed. Does it harm to install an AC with higher ton capacity than required for the room? It harms in the sense that it's going to be an expensive proposition. You'll use it for lesser time. If your set point has been set correctly, it will switch off and not work. But why do you want to spend that initial money? Because bigger air conditioners are more expensive. Roof insulation with pot mud. Yes, this is mud fasta that most of us have commonly studied in schools of architecture, and you may have seen that several times even the bigger pots like gamlas are set so that the roof and the slab can be laid with that in place. So it used to be a very common practice, but over time it has reduced because of availability of bitumen, the availability of other material as well. And if there is a more specific question, I can answer that. Yes, I have Mrs. Mili Majumdar, who is the director of the Secretary of ADaRSH, present over here to take some of the questions.
In terms of treating the water, in large condominiums, yes, it is very much advisable that the rainwater which is captured from the surfaces on which the vehicles are plying, that water should be first treated through an oil and grease filter, filtered out, and then only it should be recharged into the ground. And the roof water can be taken as it is. Oil and grease filters for the other types of wastewater which we get out of different building applications, they are usually treated through different kinds of systems, and the sizes vary based on the quantum of water that is generated. And to be more economically viable, it is advisable that you separate the grey and the black water, separate it out and treat the grey water separately because it is less expensive to treat it, and treat the black water separately, and then use it back into the building for flushing or landscaping or other such purposes. And if there is a central air conditioning system, which are mostly applicable to large commercial buildings, then it is also advisable to use and treat the water to that level and use it for the condenser water applications. So there are different ways of treating water, and the sizes of the grey and the black water treatment and the technology that you use are they vary. They can be natural systems. Some of it are say root zone or soil biotechnology based systems, which require a little bit of more space. But there are also compact systems like SAF, MBBR, and other technologies. And the grey water recycling industry, the black water recycling industry is pretty well developed, and you get these systems, and there are several suppliers of them. There is one question on materials for sealing. The roof is a place from where maximum amount of heat comes in, and the first cutoff point, like the best is that if you are able to cut the heat at source, which means if you do not allow the heat to come inside the space, it is the best. How do you do it? As it was mentioned earlier, either you let the heat get reflected out or do not allow it to reach the roof, which means that you may provide a shading. You may provide a roof pergola or a solar system to shade the roof, or you use a heat reflective paint to reflect the heat away. And the next best possible solution is to apply a roof insulation, which is in form of an overdeck insulation, which is an insulation layer which is applied on top of the roof and below the final roof treatment and below the waterproofing treatment. That is the best way how you can lessen the heat that gets circulated inside. And often there is a debate that whether you should use an overdeck or an underdeck insulation, because in terms of insulation value, both may give you the similar kind of property. But what happens is, if you cut the heat at the source, then lesser heat comes inside, because once the heat gets absorbed, then it is just a matter of time that it percolates or it penetrates towards, it comes inside the space. So underdeck insulation should be, less preferred option than an overdeck insulation, and insulation can be provided in different ways. For underdeck insulation, for false ceiling, you can use mineral wool, you can use gypsum with other forms of insulation, and overdeck insulation could be in form of extruded polystyrene, in forms of expanded polystyrene, in form of puff insulation. The cost of which varies, and it may vary depending on what material you are using, between say 7 or 8 or 9 rupees per square foot, maybe for high reflective paint, to maybe a little lower than 100 rupees a square foot. But again, these kind of costs, it varies with the kind of insulation material as well as the thickness that you are trying to achieve. But it is also important that the insulation is protected well, which means proper waterproofing and an integrated waterproofing to protect the insulation layer is very critical. There is one question on use of energy simulation tools. Energy simulation tools are very useful tools which help you to select the right kind of sizes of systems and take decisions not only on system size but different energy conservation measures that you apply to a building. However, it is equally important that the person who is using the tool understands the input and the output of the tool, because unless that is well understood, it can give results which may be very different from what happens in practice. From practical experience, we have seen that two persons performing energy simulation on the same building, the variation in numbers may be to the extent of 40%. One from the other. So to be able to comprehend the results is very crucial, and our experience says that from actual working conditions to a good simulation number, the variation should not be more than 5%, 5 to 10%, if the conditions that have been assumed in the energy simulation tool is same as is happening on field. So that is very important. Insulation certainly helps you to save energy, and I have said this earlier also, the location of insulation is very important, and it is insulation, if it is provided, it doesn't matter whether you are providing in east or west or south or north, because one needs to understand that insulation is useful in stopping or reducing your conduction gain, which is a resultant of a temperature difference between inside and outside. So though maybe a west-facing wall will receive more heat during the afternoon, but the temperature which is there, the atmospheric temperature, or rather the ambient temperature, is same all through, which means insulation should be applied equally on all surfaces of a building. It is not dependent on orientation of a particular building. There is no study on water harvesting from heat insulated, like painted roof. We are not aware of any such study that has been conducted. We are closing now, and there are some. We take questions. We are taking the questions online, and we will respond to the respective queries through email. Thank you very much.